So welcome to the ACT National Oration on Climate Change. Looks grim, but we do have many solutions. My name's Howden. For those of you who don't know me, I am the chair of the FTSE ACT Division Committee, and I'll be the MC for today. I wish to begin by acknowledging the traditional owners of the lands on which we join, both here in Canberra, the Ngunnawal people here in the ACT, but the traditional owners of the lands across Australia from which some of our online audience may be joining. I acknowledge traditional owners' continuing custodianship and connection to land, water and community, and the knowledge that is embedded in that custodianship. I pay my respects to their elders, past, present and emerging, and to all Aboriginal and Torres Strait Islander peoples that are joining us today. So the National Oration is organised and hosted by the ACT division of FTSE. And looking at the audience, I think you all know who FTSE are, because I was thinking, oh, some people might think, who are FTSE? We're the Academy of Technological Sciences and Engineering. And we bring independent, authoritative voice to issues of national significance in Australia. We're about 900 fellows. But I suspect, looking at the audience, I don't need to take your time by explaining who FTSE are. One of the things that I value greatly about FTSE is its focus on not just the big issues, but solutions. And that's one of the things that Mark will talk about today as well. Reflecting the role of Canberra and the ACT in the National Academy, we hold a national oration each year at about this time, where we bring together a leader in science, technology, engineering to present to us about an issue of significance of national importance. And we're particularly fortunate today in having Professor Mark Howden as our ACT National Oration speaker. Mark, as many of you I'm sure are aware, is one of Australia's leading climate change experts and one of our most authoritative voices. He's been a fellow of FTSE since 2022, I do believe, and he's also a fellow of the Australian Academy of Science. And through his research, his leadership and his skillful communication, Mark has been articulating the scale of climate impacts and how we can manage them since the 1990s, both here in Australia and internationally. He was director until last year of the ANU's Institute for Climate, Energy and Disaster Solutions. And I want to just note a big thank you to ICEDS, which is their acronym, the Institute of Climate, Energy and Disaster Solutions, because they've actually helped organise the event today. So I'm very grateful to them for that. Mark is also Vice Chair of the Intergovernmental Panel on Climate Change, the IPCC that is, Working Group 2. It's a role he's been doing for 2 IPCC assessment cycles. Those are sort of roughly 7-year cycles. I think you've been Vice Chair since 2015, so that's the 6th and 7th assessment reports, right in the midst of the 7th assessment report now. But apart from that, he's been a contributing and lead author and editor of the IPCC since the early 90s. In fact, I think he takes the record of one of the longest standing contributors to the IPCC process. He was until last year, so the immediate past chair of the ACT Climate Change Council. His career spanning more than 4 decades, he's worked in CSIRO, Bureau of Rural Sciences, Resource Sciences? Both. Both, and I think it's changed its name since, as well as here at the Australian National University. And throughout that career, if you wanted to characterise it in a sentence, I would say it's about developing innovative ways to manage climate risk and respond to the challenges of climate change. And he's applied much of his expertise and that innovation to agriculture and food systems, as well as to achieving broader environmental outcomes. Apart from all that, Mark is an outstanding communicator and is very committed to educating and informing the wider community and government. He gives many presentations, interviews and briefings. So we really are fortunate today, given his background and experience. There are a few people better qualified to talk to us today on that important topic. So I won't take any more of your time. I will hand over to Mark. Just to note that at the end of Mark's talk, there will be a chance for Q&A. I'll draw your attention for those that are in the room who feel they need to be on Wi-Fi, that on this holding slide, if you go to ANU Secure and enter the username of FTSE Oration in caps and the guest password FTSE Oration also in caps, you'll get onto Wi-Fi. But I hope that actually you'll be mostly listening to
Well, but firstly, thanks very much, Helen, for that introduction. Thanks everyone for turning up today on a wet but rather warm winter's day. So what I'm going to talk about today is essentially just a little bit on the sort of reality of climate change, and then a little bit about the solutions, the sort of good news stories that we are doing, but perhaps need to do a lot more of if we're to get serious about climate change. And it's really great to see people who have been in this sort of business, like Brian and Andrew and Pep, for a long time participating today. So this is one of the slides that I always put up first, and it's great that Pep just walked into the room, because Pep's been a key sort of driver behind the Global Carbon Project, and this stems back from GCTE days when Brian started the Global Change and Terrestrial Ecosystem Program way back in the 90s. And so they continue to produce really informed information on the global carbon cycle, nitrogen cycle, methane, etc. And it's a core piece of information if you want to understand what's going on in terms of climate change. The picture here is not great. What it shows is that carbon dioxide, in this case from fossil fuel combustion, industrial emissions, etc., keeps on going up. Apart from two little dips, global financial crisis and COVID, we see those emissions continuing to go up and up. And we continuously break those records. So last year broke the previous year's record, which broke the previous year's record, etc. And so we're really not taking our foot off the climate change accelerator, as indicated here. And we understand very clearly the link between these emissions and global temperature rise. And we've done so now for 201 years. So this was first figured out back in France in 1824, I think it was. So you know, we're failing to actually do the said we do under the Paris Agreement. If we were to actually do something like meet the Paris Agreement targets, we actually would have to go on a trajectory indicated by that dashed line. And so that dashed line would not only have to go down to the bottom of that graph, it would have to go halfway to the floor, down to the zero line. That's the challenge ahead of us. And you can see how we're completely failing to meet that challenge at a global scale. And what this does, of course, is it commits us to future change, future temperature change. And at the moment, we're roughly speaking, come in, John. At the moment, we're sort of heading towards 2.7 or 3 degrees, more or less, depending on what happens with future trajectories, emissions trajectories. Now, at the moment, because of the cumulative nature of carbon dioxide in the atmosphere, we see that growing very quickly. We're currently at 430 parts per million, which goes up and down seasonally, but compared with 280 parts per million pre-industrially. So we've increased that by more than 50%. If you look at other greenhouse gases, and that's well above 1.5 degree consistent pathways. If you look at other greenhouse gases like methane and nitrous oxide, again, we're accumulating those very quickly in the atmosphere, and methane is getting towards tripling the pre-industrial concentrations. So, major changes in the atmospheric composition that we're generating. And when we look at our carbon budget that's consistent with sticking to 1.5 degrees, we have almost no time now before we run out of that budget. So it's less than 3 years, probably about 2 years at current rates of emissions before there's a 50-50 chance that we've actually run out of our budget, our emissions budget that's consistent with 1.5 degrees. So there is a sense of urgency that needs to be adopted when we're dealing with climate change, I would argue. Now, as I said, we've known for 200 years that if we put in greenhouse gas in the atmosphere, we'd warm the Earth. And that's exactly what we see. This is a graph from the World Meteorological Organization showing temperatures back from the mid-1800s up to last year. And we can see that not only is temperature going up, but it's actually going up faster and faster over time. So it's accelerating just as concentrations of carbon dioxide in the atmosphere have gone up. And last year was the equal third hottest year on record. My assessment is that this year will be the equal hottest or the hottest on record, courtesy of the El Nino that's brewing in the Pacific. And last year was just shy of 1.5 degrees. And even though it was actually a La Nina, which tends to cool global temperatures down roughly by about 0.2 degrees Celsius, is what a La Nina cools down things. And looking at last year, for the very first time, the 3-year average, that's 25, 24, and 23, was above 1.5 degrees. So we're right on the cusp of 1.5 degrees on a trend basis. And I would suggest that we're actually likely to exceed that either this year or next on a trend basis. And I say on trend basis because there's different ways of assessing global temperature. And this means that we're actually in very much uncharted territory. You know, there is no time in human history, so let's say the last 190,000 years, where we've had anything like this sort of temperature or anything like this rate of change. So when we look at what this is already doing in Australia, it's not great, and you'd all be aware of, I think, most of these things. So we've got, you know, extraordinary heat waves on land and in the oceans. Just 2 years ago, 3/4 of the oceans across the world had at least one heat wave event. This is quite extraordinary now. Increased bushfire risk from drought risk. We only have to remember back to the Black Summer. We've had stronger and more damaging floods, storms and cyclones. Cyclones are coming further south. If you think of Cyclone Alfred, getting almost down to Brisbane. Overall, we've got less water in our rivers, but it's more peaky. So we're getting, the floods are bigger and the dries are drier than they used to be. And the Murray-Darling has now dropped to about 40% reduction in flows, which on average, which includes a climate change component. And John Williams can talk about that. He's published on that. We've got lower and more variable food production. So our food production is well below what it would be in the absence of climate change. And it's increased variability is driving the ups and downs in that. We've got major animal welfare issues, which are almost most Australians are completely blind to as a result of climate change. So if you go back just a few years, 2/3 beef cattle died in the Gulf country because of a combination of climate events. About 200,000 died as a result of Cyclone Alfred and the floods in Queensland. This is extraordinary. The things that are happening due to climate change, which we are often just completely unaware of, partly because of media reporting. We're seeing increased physical and mental health issues associated with climate change. So we see increased hospitalisations when you get hot days. We see increased mental health and domestic violence when we get hot days. These are becoming significant policing issues as well as policy and other issues. Of course, we're seeing rising sea level, and that's becoming increasing a concern as we start to see breakdown of significant ice sheets in Antarctica much more quickly than we anticipated. And some of the really big ones like the Thwaites Glacier are about to actually lose their grounding point, which holds back the ice from getting into the ocean. And as associated with that, we're also seeing increased wave energy. So as the world heats up, your average wind speed goes up and your average wave energy goes up. So you've got a rising sea level and increased erosive potential against your coastlines, and that's generating erosion in many parts of the world. We're also seeing a loss of biodiversity, and that's been studied particularly here in ANU, and loss of ecosystem function. And we, unfortunately, here in Australia, we've been the host of the first mammalian climate change extinction, and that happened in the Torres Strait Island with the bramble key malomus died. This is a little rodent-like critter used to live on the low-lying mud islands in the Torres Strait. Climate change means that those islands no longer exist and that creature no longer exists. And that happened in our country on our watch. So these are things that are already happening. And economically, Deloitte's assessed that this costs Australia about $38 billion a year. So, think a tenth of the AUKUS budget, if you want to put it in AUKUS terms. But that's extraordinary. Like if we could save $38 billion on some other topic, other sort of government outlay, we'd jump at it, but we don't jump at climate change. And of course, more emissions and more climate change makes all of these things worse and worse over time. So what does the climate science community say we're heading towards in terms of temperature? The answer is not good. So this is a survey done by The Guardian a couple of years ago, surveyed about 450, I think it was, climate science across the globe. I was surveyed, I think PEP was also surveyed, and almost 80% of us saw that we were going to hit at least 2.5 degrees. That was our assessment of where we're going to go, and almost half anticipate at least 3 degrees. To put 3 degrees in context, our last ice age was roughly 5 degrees colder than our historical temperatures. That last ice age generated kilometres of ice over North America, Europe, South America, and our sea levels were 120. That's 120 metres below where they currently are. That's what 5 degrees does. So what we're heading towards is 2/3 of that sort of degree of change, but obviously in the other direction. You can't have 3 degrees change globally if it's sustained and not change the face of the world. This is huge. It doesn't sound like much, but it is really, really large. So when we asked, or when Guardian asked who was to blame, so 3/4 of the surveyed participants said that lack of government willpower was a critical thing, and 2/3 said that corporate vested interests were also to blame. And importantly, younger scientists and female scientists were much more pessimistic than the average. These are people who are increasingly feeling the concerns about the future that they're inheriting. If we look at what might happen in the future, these are different trajectories coming out of IPCC temperature trajectories. We have at the bottom of those temperature trajectories on the left-hand panel, that's what we call an overshoot scenario, where we temporarily go over 1.5 degrees and then bring it back. So you could think it was of an exceedance and return sort of scenario. And at the moment, I think we have to say that our chance of not overshooting to some extent, going over 1.5 degrees, is about 0, unfortunately. And so the best we can happen is go over and then bring it back down. To bring it back down, we have to take out huge amounts of carbon dioxide out of the atmosphere, negative emissions activities, which at the moment are much more about corporate marketing than they are about reality. And so we have a serious challenge. We've got a scientific challenge, a governance challenge, an economic challenge if we are to actually bring those carbon dioxide levels and temperatures back down. What seems much more likely is we're going to go up above 1.5 degrees, can keep on going for a while. The question is, at what level do we stabilise those temperatures? Is it at 2 degrees? Is it at 3 degrees, or what? And the bars on the right-hand side are some of the what we call burning embers in the IPCC, which came from the last assessment. And those colours indicate risk levels. There's 3 different topics there. It doesn't really matter which topics, but essentially as you increase your global temperature, the risk associated with, say, coral bleaching or extreme events, etc., keeps on going up. And so as you can see, the more we let climate change run, the more risky our world becomes. Well, given that sort of scenario about emission reductions, how's Australia going? And the answer is pretty mixed, I think. So these are DQ figures. I'm not sure where the projected emissions numbers came from, and what they're based on. But what this shows in the dark black line is where we've come from, going back to 2005. So there has been a significant reduction in net emissions across the globe during that time frame. But much of that has been driven by reductions in land clearing and also activities on farm to sequester carbon. When you actually look at the non-land use change figures, we really haven't made much progress at all. And in fact, over the last handful of years, we've been flatlining in terms of emission reductions from the when you take out the land use change component. Over the last quarter, we've actually started to see more significant reductions in transport and also in the electricity sector. So there is progress there, but not a lot of progress in the other sectors. To get to the 2030 targets, which is indicated there, we have to significantly change that rate of progress. So instead of roughly flatlining, you can see over the last few years, we actually have to start pushing down those emissions. And if we're to get our 2035 target, which is 62 to 70% reductions against 2005 levels, we'd have to continue that much steeper emission trajectory than we have in the past. That means either our existing policies have to start to cut in a lot more than they currently are, or we have to put in a whole range of new policies and behaviours to drive down emissions. And our stated aim is net zero by 2050. That is going to be a challenge because there's a whole stack of hard to abate options sitting in there. Things like airline sort of travel, amongst others, still making activities. But there are solutions to that. We're just not sort of grabbing them at the moment. But even if we go along that trajectory and hit net zero by 2050, and everyone else did that, we're still committing the world to around about 2.2 degrees Celsius increase. So it doesn't, the trajectory we're on is pretty marginal in terms of meeting our Paris Agreement targets, and certainly is not consistent with 1.5 degrees. So that's the sort of bad news story, is that there's a lot happening and it really matters, and that we're probably not at a national scale taking action fast enough. However, as part of the title, I was actually saying, there is cause for hope and there are good news stories, and people around this room have participated in many of these. So if we look at renewables, they're growing rapidly in our electricity system. So, for example, South Australia and the ACT are now well past 100% renewable powered. And that's a great story. There's very few jurisdictions globally which actually can claim that. And this is in part because of government policy decisions. It's in part because of the preparedness of Australians to stump up their own money to put solar panels on their own roofs. So that roof-based solar panel installations are a big part of the Australian energy system now. And almost all of those panels actually have technology that Andrew Blakers was critical in developing, the PERC cell. So something close to 90%, as I understand it, of cells, solar panels across the world have that technology in it. Australia isn't reaping the benefits of that, of course, because that was bought out and owned overseas. One of the many challenges we have converting good ideas and research into value for Australia. When we look at the NEM, the East Coast grid, that's now 46.5% renewable. The West Australian grid is a little bit more than that. So that's the last quarter. So we're rapidly building up the amount of electricity in our grid system. And remembering it was only a handful of years ago that politicians were telling us our grid could not cope with more than 10 or 15% renewables in it. And yet we're now getting close to half. It tells you something about our politics, as well as it tells you something about how we can innovate to make these things happen. And there's been a huge amount of policy, a huge amount of funding that supports that expansion of renewables in our electricity grid. And so the Capacity Investment Scheme in the Commonwealth, the reverse auction schemes here in the ACT are just examples of that, where innovative policy has actually generated really great results in our systems. As a result of this, wholesale prices are coming down. If you look at the last quarter's prices compared with the year before, they're down around about 40% on average across Australia. That's huge. And that's largely because of that penetration of renewables, pushing out expensive coal and pushing out even more expensive gas. And And at times, those prices are going negative. So there's an excess of electricity in the grid, and so you can actually get paid to use energy. And if you think about that, it's an extraordinary circumstance. That, what used to be a valuable commodity, energy, you now actually get paid to use. It's a complete inversion of the market-based systems that we've had in the past. And as a result of that, we now see policies which are being tested. That's the solar sharer offer system, which is now being tested in South Australia, New South Wales, and South East Queensland, where the Commonwealth has said you have to be able to, retail companies offer options for retail with 3 hours a day of free electricity. So you can actually have a battery and suck in as much as you want, well, up to a limit, for 3 hours a day, and then use that as you want, which is, again, quite extraordinary if you actually think about it. That's a result of these policies which have really, really ramped up renewables in our system. And I'll talk about batteries in a minute because they're a big part of it. However, in spite of that, all of that good news story, we have some significant issues in terms of transmission and putting in new transmission lines because of social license issues. We've got significant issues in terms of approvals, and the politics of Australia are not great in terms of that. One Nation is very anti-renewables. The Coalition, who are lurching even more to the right, are very anti-renewables, and that will limit federal support for that in the future if they get into government. And of course, how much EV penetration there is and how they operate within our electricity system, what happens with data centres, how they operate within our system are big unknowns, and they also will need to be taken into account. But having said that, there are those cautionary notes. I think it's really important to acknowledge the achievements that we've had in terms of this energy transition. This is a graph which actually only came out today. So it's actually from a Farmers for Climate Action publication. Ray Wills put it together. I haven't actually gone back to the raw data, so I'm just having to accept it as it stands. But this is essentially energy transitions from different energy systems in the past. So the curve of adoption of hydro, of nuclear, of oil, of gas and coal. And you can see all of those, in a sense, legacy energy systems. They've taken a long, long time to build up in terms of the contribution to the total energy system. In contrast, if you look at the wind one, which is the sort of lightish blue colour, you can see that that was a much faster transition than any of the previous fossil fuel-based or nuclear transitions. The sort of orangey coloured one, I think it's the solar transition, even faster again. And if you look just down on the bottom left, that's the battery transition, and you can see that that's faster again. So what we're actually doing in terms of renewables and batteries is not only the most amazing transition, it's actually the fastest energy transition we've ever seen in human history. This is quite extraordinary, and this is what we're living through day to day. And so in terms of batteries, which are increasingly important, because the challenge has always been we haven't had an energy production problem, we've had an energy storage problem, and batteries are one way of addressing that, but there's also pumped hydro, of course, and various others. So under the Cheaper Home Batteries program from the feds, they've put in something like 400,000, maybe 420,000 new batteries, which is 11.4 gigawatt hours of capacity. So the average coal-fired power station in Australia is 1.5 gigawatts. So it tells you how much battery capacity is actually coming into stream these days. And that's shifting energy consumption from the daytime peak, which used to be, so that's now a storage peak, and it's pushing it into the evening peak, and it's pushing down on that peak consumption and pushing down on prices. So we're seeing, fundamental changes in time of use of energy because of batteries. The batteries that are already in Australia cover around about 11% of a day's consumption. and that's grown very rapidly. So we're really changing our energy systems, in ways which we wouldn't have seen feasible just a few years ago. And projected penetration of that policy is about 2 million home batteries, household batteries, by the end of the decade. And that will add something like 40 gigawatt hours of storage to our system, maybe more than that, depending on how big the batteries are. And this is, in addition to that, is the grid-sized thing. So the big Hornsdale type battery facilities, which are fundamentally changing the nature of electricity supply and delivery across Australia, and improving it as well. And as well as this, there's many other energy storage systems being looked at. So there's pumped hydro, and Andrew's done a lot of work on that. There's compressed gas storage systems. There's hydrogen storage systems, both liquid and other storage systems. And there's different battery technologies which are being developed. And so we're moving away from the more liquid-based things to semi-solid state and solid-state batteries. And there's even quantum batteries which are now being explored, which have effectively instantaneous charging capacity. And so one of the things that struck me over the years is just how Australia has successively missed the boat on investing in R&D on battery technology. This is such a huge part of the world, and effectively all of it now is owned by the Asian countries. So it's China and Korea and Japan, and very little battery technology and production systems are actually held in the West. If we look at transport, it's a good news story as well. So we've seen really big increases in electric vehicle purchases. So last month, nationally, 20% of new cars were electric vehicles. So this is straight battery electric vehicles. And in the ACT, as we have for a long time, we've been the champions of electric vehicle adoption. And so last month, or in May it was actually, there was 36.5% of the new vehicles were battery electric vehicles, which of course means that 2/3 weren't, but at least we're actually moving up in terms of the percentage. And to compare this, back in 2022, nationally, only around about 3% of vehicles were electric vehicles. So we can see how much Australians have now got over the political messaging of electric vehicles will ruin the weekend, and they've actually decided that instead electric vehicles actually are a pretty darn good thing. And importantly, now electric vehicles have passed the cost parity point with fossil fuel vehicles. Now, over the lifespan of the average electric vehicle, it's cheaper to own than it is to actually buy a fossil fuel alternative, and it's getting cheaper all the time. And so, so that's a really important point, because then it makes economic sense, financial sense, for people to go electric rather than fossil fuel based, apart from all of the things about volatility of petrol prices due to Strait of Hormuz type stuff. The thing that is lagging behind are trucks and tractors, although there are trucks and tractors now coming that have electric power. They just haven't really got a lot of penetration here in Australia, even though they have in places like Europe. Tractors are a big problem, not so much for the small tractors, but big tractors. And there's power and heat dissipation issues that are still being worked through. But the big suppliers like John Deere are bringing out tractors, and that's one example from overseas. They just haven't been brought to Australia yet. So later this year, apparently, it's going to happen. And one last comment is our rail system here in Australia remains absolutely poor. And just as an example, just last week I was in Italy. I was just catching an average everyday slow train over there. A slow train still peaked out at 160 kilometres an hour. Like we would dream about having a fast train that did that. We are just so far behind in terms of rail systems. And there's lots of other good news stories scattered across different sectors. So heat pump take up for space heating and also hot water heating is getting faster and faster. The gas usage is dropping quickly, so it's dropped about 16% from the peak And we're entering into a situation where the gas death spiral is a very real possibility and happening over a relatively short period of time. And even just yesterday, I saw a story in the news, which was Albany in Western Australia. The gas company that supplied the gas there basically saw the writing on the wall and is completely pulled out. So that's not a hypothetical thing. This is actually a real thing where the gas system just becomes unsustainable with a smaller and smaller user base. We have some governments and businesses reducing their internal emissions profiles, but we also see businesses continuing to invest heavily in fossil fuels. And so that was just a headline from the other day. World's largest banks pushed almost $1 trillion worth, US dollars, of investment into fossil fuels, in spite of the fact that we need to actually be pulling out of fossil fuels. So on the one hand, you say yes, climate action. On the other hand, you actually promote the ongoing usage of this. In terms of energy efficient buildings, we do have programs in Australia, NATAs and others, which are pushing towards energy efficient buildings. But really, there is so much more to do. You know, the passive house standards, which is, you know, just normal in Europe. You know, double, triple glazed windows, thermal break windows and things like that are still hard to find in Australia. They're still expensive in Australia. We need to improve that. However, having said that, there's limited progress on fugitive emissions. So there's emissions from, say, gas extraction or coal mines, even though there are apparently cost-effective ways of reducing those in many circumstances. Industrial emissions remain pretty stubborn in Australia, particularly high heat related systems, and even though there are alternatives, they're often not well used in Australia, so they're not part of our culture yet, and so they're not well used. And agricultural emissions are effectively untouched by sort of climate change concerns at this stage, even though there are some government programs sort of pushing in a little bit of R&D onto that. So one of those things, and I put down deliberately, that some of those programs support pretty questionable options. So one of those options is Asparagopsis, red seaweed, sometimes it's called. So this is fed to animals to reduce their methane emissions. Asparagopsis is toxic. It's a carcinogen. It's a teratogen. It's also one of the major weed species, marine weed species in the world. Emits bromine, which is a greenhouse gas into the atmosphere. It's not cost effective, and you have to have constant input into the animal to reduce emissions, which means that it's unusable for the majority of animals across Australia, which are grass-fed rather than stall-fed. And so why would you actually put in R&D money when there are safer alternatives which do exactly the same job? And so there's some really questionable decisions being made in terms of these things. There's also really good news, I think, in terms of the policy environment. So there's been a couple of really interesting papers coming out recently which look at emission reduction policies across the globe. And the one by Fernandez and Marin did a really interesting job. It was across 40 different countries, 32 years, 1,800 different policy instances, and they looked at which policies worked. And then they said, okay, well, let's cluster those. And so these are a few of the things that came out of that. So policies that demonstrably work across the globe. Firstly, putting a price on carbon. So whether that's a market-based system or a cap and trade type system, or whether it's congestion charges in cities, it works. And it demonstrably works. There is no reason why we shouldn't be thinking about this in Australia. Energy efficiency and standards. We actually do a reasonable job of that in Australia. So that's building energy codes and appliance standards, increasingly, our national vehicle emission standards and other things. And so we're actually not doing too badly on that. Renewable energy R&D. So that's energy expenditure on renewables, application of renewables, next generation of these. It's on carbon capture and storage, negative emissions technology. In Australia, it's pretty patchy. We put in a lot in terms of the implementation of these technologies, but not a lot in R&D. And I think, Ken, you were talking just recently about how the R&D for renewables is actually dropping in Australia, which is a mind-bogglingly stupid thing, if you actually think about it. The time when we should be investing in this is right now, not disinvesting in it. Reporting and accountability is important from a government perspective, not only at a national perspective, but down at business levels, and in terms of products with life cycle analysis. And so that's an area where Australia has, again, patchy sort of performance, and subsidy reduction. We're not doing really well at that at all. So as I'll mention a little bit later, this is a huge thing across the world, and it's a huge thing in Australia. So depending on your source, between 11 and $14 billion a year is provided in direct subsidies to fossil fuel companies and fossil fuel usage across the globe, across Australia. And globally, that number is $7 trillion US dollars. So this is really, really substantial. And so that's one of the things we've got to focus on. And one of the key things that came out of this particular study was that multiple pathways exist to reduce emissions. There's no single pathway. You can mix and match many of these different policies, as many countries have done, and actually get really good results. And so there's no excuse for not actually saying, from this huge policy menu, choosing the things that work in the Australian context or the different jurisdictions in Australia. Now, moving on to adaptation. So globally, progress on adaptation is patchy at best. This is a few comments in relation to the global sort of situation. So the top one is a quote from the last IPCC assessment. It says, unfortunately, most observed adaptation is fragmented. It's small in scale, incremental in nature, sector specific, so it doesn't learn, you don't get learning across sectors, designed to respond to current impacts on near-term risks and focusing more on planning rather than implementation. In other words, talking, not doing. That's not a great scorecard in terms of adaptation globally. Looking at distribution, it's unequally distributed across regions, and the largest adaptation gaps, so the difference between what's happening versus what's needed, exists in lower income population groups and other disadvantaged groups. So money's not going where it's needed. There's limits to adaptation which are being reached in some systems, and our existing array of adaptation options were assessed as becoming less and less useful as climate change progresses. So we need more adaptation tools in our toolkit, and we're not investing in those new adaptation options. Again, not a great story. And finance globally for adaptation is insufficient, with a big gap between what people and countries said they were going to do and what they actually have done. And if you look at this global story and then take all of this stuff and put it across Australia, every one of those comments applies to the Australian circumstance. So ever since about 2013, when the climate adaptation flagship in CSIRO was killed off, when NCARF, the National Climate Adaptation Research Facility, was killed off, when most of the state-based adaptation activities were killed off, we have basically been investing in adaptation, and it's a fundamental problem for Australia. And it's a fundamental problem because there are many, many, many sensible adaptation options that we can identify right now. And in the IPCC, in the last cycle, we assessed different adaptation options and the feasibility of them against different criteria. And we found that there were many, many different options that were feasible in different circumstances. Many of them could also be used to reduce greenhouse gas emissions at the same time. And almost all of them, if well designed and implemented, could assist with sustainable development goals. So Australia has signed up to those 17 sustainable development goals. So there is, a really strong rationale to actually take adaptation much more seriously. When we look at the costs and benefits of adaptation, they're pretty clear. There's plenty of evidence about this now. So some of the benefits of effective climate adaptation is that it avoids the costs of climate change impacts. If you have an effective adaptation response, it reduces those costs. If you have opportunities that arise from climate change, effective adaptation grabs hold of those opportunities and makes the most of them. Effective adaptation can increase labour productivity, for example. It opens up new opportunities. You can get many, many different ancillary benefits from it. And effective adaptation empowers people and reduces psychological stress. There's good studies on that now. Unfortunately, it's poorly quantified at large scale and hence not particularly of interest to national policymakers who operate at large scale. This is because adaptation is often local in nature and it's highly contextual and diverse because of that local nature. And it varies on often very fine-grained scales. So different solutions can apply for different companies or different farmers next to each other, depending on risk tolerance or circumstances. There can often be upfront costs, which are significant and which can be dealt with by effective policies. So, for example, an upfront cost is Indonesia is about to put in like an 800-kilometre long seawall, concrete seawall, to protect against climate change. The upfront cost of that is going to be massive. The greenhouse gas emissions associated with that are going to be massive, and in the long term, it won't work. It's probably going to generate huge amounts of unwanted consequences on fisheries and on inland water flows, etc. It's probably a pretty dumb idea, but the fundamental point that I was making there is there's an upfront cost for adaptation responses. Nevertheless, on average, an effective adaptation response is a really good money-making proposition. So when you look at assessments of adaptation across the globe, pretty much for every dollar you spend now, you'll get somewhere between $2 and $17 back, and a good average number is $10 or $11. So if you were thinking in commercial terms, if you could outlay $1 and get $10 or $11 back, you'd be going for that like you with your ears back. You would have, you'd be putting as much money as you possibly could into that bucket because the returns are so strong. And just reinforcing that, the World Resources Institute did a recent study across 12 different countries looking at those returns on investment, and the numbers were staggering. So they were looking at 1.4 trillion US dollars returns over a 10-year period, and the average internal rate of return was 27%, and for some sectors like health, that was much, much higher. Those are rates of return that any commercial entity would love to have, and yet we're not putting that in investment. So what's stopping us from adapting? One of them is leadership. So we haven't got here in Australia leadership that acknowledges that climate change is real, that it's impacting on Australia, and that we can do something about it through adaptation as well as emission reduction. It would be lovely to have a Prime Minister who could actually get on the media and actually talk in an educated and coherent way about these topics. Unfortunately, at the moment, we don't. We need resourcing, resourcing which is proportionate to the challenge and the opportunity. If Australia it's costing us $38 billion a year, well, surely we should be able to do more than the scatty little money that we're putting into it at the moment. We have a cost-based framing. People worry, what's the cost of adaptation? They don't actually look at the benefits of adaptation. I mean, there is no other human activity where you would only ever look at the costs and ignore the benefits before making an informed decision. You would always look at both of those. And in the case of adaptation, you'd look at the tangible and intangible, the economic and non-economic elements as well to actually get a sensible decision. And yet we're not doing that. There's uncertainty, which is part of the thing that stops us. So people say, well, there's a lot of uncertainty about how much climate change is going to occur. So that means there's uncertainty about how much adaptation we'll need. So because of that uncertainty, we won't invest. We've gone a long way past that in terms of our science. There's also a lack of a strong culture for adaptation in terms of government and business in Australia. So we haven't got that bedded in, even though that is starting to come through in the disclosure commitments that are needed in business. We've got misinformation and disinformation propagated by some of Australia's potential alternative government people, which dismisses climate change and dismisses the need to act on climate change. And this poisons the well of commitment because uncertainty muddies the waters and it reduces the likelihood of investment, and it reduces climate literacy because people aren't sure about what's really going on. So I would argue that we need robust and fit for purpose governance arrangements for adaptation, which are long-term in their nature to match this long-term issue. So just pulling that together, the last couple of slides, is that what's in the national interest here? And I would actually argue that it's very clear that taking climate change seriously on both the emission reduction side and the adaptation side is actually in our national interest. And when you look at the numbers, if you just want to make a purely numbers, economically based thing, it's fairly straightforward. These are numbers coming out of Deloitte's and the investor group of climate change. Inaction could cost Australia between $3.5 trillion and $6.8 trillion in foregone sort of money, GDP, and almost 1 million jobs in the next 20 to 50 years. Whereas action could actually grow our economy by close to $1 trillion, by 2/3 of $1 trillion, and another 250,000 jobs. The contrast is very clear. Action on climate change is a much, much better bet than inaction. And at a global scale, numbers are that inaction will cost about $178 trillion in this case, but action generates a $43 trillion boost. The pure economic rationale for taking climate change seriously is very, very clear. And if we actually expand that, it's not just about the economics. There's legal and moral dimensions of this as well. And now the recent International Court of Justice case on climate change launched by Vanuatu, and this is their advisory opinion, is that preventing climate harm is a legal and I would argue a moral obligation, not just a political choice. So this is what their opinion was. And they said that continuing to expand fossil fuel extraction and combustion is a wrongful act, as assessed by that court, as is granting of licenses or providing subsidies or other support, things that Australia continues to do at very large scale. And as I mentioned before, one of those subsidies, in Australia, we spend maybe up to $14 billion in direct subsidies. Globally, the IMF calculates that that's about $7 trillion a year of direct and indirect subsidies to the fossil fuel industries. Imagine what you could do with $7 trillion as alternative expenditure. It also said that failing to take action to limit fossil fuel emissions is also a wrongful act. So that puts the acid on our policy, but it's unclear how this is going to propagate across in the Australian circumstances. Maybe it's going to come through the courts. Now, the last slide, Helen, because I can see you standing there, is just a quick summary of this. So climate change is already costing Australia dearly. That's what the science says. That's what the evaluation is. And these costs are likely to grow and grow rapidly. There are reasons for hope in terms of climate change, but only if we take action. Hope is fundamentally dependent on us taking action. Just hoping by itself is not good enough. It won't do anything. It's only when you start to act on that something happens. When we look at emission reduction, it's clear that it's pretty well supported by Australian governments, national and others, and there is progress in some sectors, but much more is needed if we're to meet our international obligations and to keep climate change down. And it's clear that it's in Australia's national interest to keep climate change limited. If we look at climate adaptation, it's actually currently very poorly supported by Australian governments. And I think ATSI could actually play a role in enhancing the co-design, implementation and operation of adaptation and shape this as a key pillar, not only of a renewed innovation system in Australia, as the Academy of Science just recently put out a paper on, but also a fundamental pillar of our international development obligations, because at the moment we're dropping the ball on those in terms of climate responses. So I'll just leave that there and happy to answer